So section 1.7 is mainly about inverse functions. And for inverse functions, or to find them, if you swap the domain, which is your x, and the range, which is y, of a one-to-one function, then this creates the inverse function. And there's a couple things I want to talk about with the inverse function. A function and its inverse are symmetric about the diagonal line y is equal to x, as well as the original function must be one-to-one, meaning it has to pass the horizontal line test. Otherwise, the inverse will not be able to pass the vertical line test. So I have two examples here of functions. So with this first one, if we reflect it across the diagonal line, it looks like this. And you'll see how the original one passes the horizontal line test, meaning it only intersects it once. So the inverse passes the vertical line test. It only intersects it once, which is very important because it has to pass the vertical line test in order to be a function. But if we look at this one, if I reflect it, then my new function looks like that. And if you look at the original, it does not pass the horizontal line test because this intersects it in more than one location. And the reflection, or the inverse, does not pass the vertical line test. So that's not even a function. So this is a prerequisite for getting an inverse is you need to be one-to-one. You need to pass the horizontal line test. Otherwise, you won't be able to pass the vertical line test if you find the inverse. So we're going to be algebraically finding the inverse, and there's a couple steps to do this. First, you want to express f of x as y, so you want to take it out of functional notation. Then you want to swap your x and your y. You're swapping your domain and your range. Normally, you're just not allowed to change x and y in math. This is one of the few cases where you just change your x and your y. And then you want to solve for y. And then we need to label the final answer as f to the negative 1. That's the notation to mean f inverse. So if we look at 5, again, my first step is to not write it in functional notation. So I don't want to use f of x, I want to use y. Then I want to swap. So instead of y, I'm going to write x. And it's going to be minus 1, 3, y. So I've just completely switched where my x and my y are. So now I need to solve for y. So I need to subtract 1. And then I need to divide both sides by negative 3. So my final answer, now that I've solved for y, is f to the negative 1 of x, or f inverse of x, that's how that's read, is equal to x minus 1 over negative 3. And that'll be our final answer. Now, if you had chosen to solve to the other side here, so let's say at this point here, so I have x is equal to 1 minus 3y. Let's say you added 3y to both sides. That is technically legal to do that. And then you subtracted x from both sides. And then you divided everything by 3. Then you'd get f inverse is equal to 1 minus x over 3. If I compare this with my original answer, I have a positive x here and a negative x here. I have a negative 1 here and I have a positive 1 there. I have a negative 3 here and I have a positive 3 here. So if all of your answers are the opposite sign, then it's actually the same thing. And I'll show why. But for these inverse problems, you really have two answers, and they are equivalent. So if you get a different answer than the back of the book, or a different answer from me, you could still be right as long as all of your signs are the same. So let me show you why these are identical. Again, you don't need to do the problem twice. I'm just showing you why your answer may still be correct, even if it doesn't match my answer. So the reason why these are equivalent is, let's say you factor a -1 out of the top. So you get -1, that makes this a negative x plus 1 over -3. Then these negatives would cancel out, and you'd be left with a negative x plus 1 over positive 3, which the other way of writing that, oops, I'm trying to zoom out, the other way of writing that would be 1 minus x over 3. So the two are equivalent just by factoring out a -1. So again, if all of your signs are opposite, then your answer is still okay.